Okay, so what we are going to do is we are going to discuss backtracking. And what I'm going to discuss is what I'm calling a magic function. Why? Because it's a simple, very simple function, but we can use it to solve a lot of questions asked in the interviews, like binary sequence, M-Ary sequence, permutation, combination, generating all the subsets of a given sum, subsets of size k, n queen problems, and probably some more questions. So let's see what is let's start with a binary sequence, and then we'll move on to M-Ary sequence. So what is a binary sequence? Let's say n is equal to 2. So the binary values are 0 and 1. So the different values that for n is equal to 2 would be 0 0, 0 1, 1 0, and 1 1, which is 2 to the power 2. If n is equal to 3, in that case the values would be 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and 1 1 1. So these are the different values. So for n is equal to 3, it will be 2 to the power 3. Okay. Let's see how we can actually use backtracking to generate all these sequences. So what we need is the value of n. So let's say the value of n is 2. Next, what we need is we need a result array. A result array would store the values of the result values that we need to print out. And we need a current pointer. So the current pointer initially would point to 0th location. So how it works is you start, and then since there are only two values, you'll go and put the value at 0 at the current location 0. Then you will move the current to one location, and then we'll put the value 0 again over here. Now this is 0 and 0. The result array is full, so we'll print this value. Then what we'll do is we'll backtrack again to 0, and then we will see for the next value we'll put a 1 over here. So we'll put a 1 over here. This is 0 and 1. Now the result array is full. We'll print this value. We'll backtrack again to 0. All the values of 0 are done, so we'll go back, and we'll for the 0th location we'll put a value 1. So now we have 1 over here. The current value will be incremented to 1, and then we'll put a 0 over here. When we put a 0, this result array is full, so we print its value. We backtrack to 1, and then we change the value of 0 to 1. And since the array is full, we will print the value, and we are done. So let's see how we can actually do this using a very simple function, which will be used at a lot of other places too. And we will write the code for it, and we'll walk through the code. Okay. I would delete all this and delete this. Okay. So the first thing that we need is we need a function where we can generate the sequence. So we will say public static void generate binary sequence with value integer n. First, what we will do is we'll check the error conditions. So the error conditions would be if n is less than or equal to 0, return. So we'll just return if n value is less than or equal to 0. Next, what we will do is we will actually create an array. So we'll say integer result is equal to new integer of size n. Okay. After that, we will call a recursive function. So we'll call generate binary sequence. The things that we need in this recursive function is value of n, result array, and the current pointer, which is 0 at this point. So now we will write the recursive function. Generate binary sequence, integer n, integer ARR result, and integer current. Okay, so the first thing that we do in a recursive function is we will figure out what is the base condition. So the base condition is if current is equal to n, in that case what we will do is we'll print result. So we'll call a function print result and we will return from here. Now let's write, we don't have the print result function, so let's write the function. Okay, this is a very simple function. All we do is we just print the results. So for integer I is equal to 0, I is less than result dot length I plus plus, and we will do console dot write, and we'll write result I plus tab just for visual purpose, and we'll say console dot write line. Okay, so our result function is printing result function is done. Next step, what we want to do is we want to actually change the value in the result array and then recursively call this function. So there are two, this is a binary sequence, only values is 0 and 1. So we will have a for loop for 0 and 1. For integer I is equal to 0, I is less than 2, I plus plus, why 2? Because 2 is the this is a binary sequence. So first what we will do is we will say result of current will be equal to I, and then we will recurse with result and current plus 1. Why current plus 1? Because we have already changed the value of the current, and now we want to change the value of the current plus 1. So I think we are done at this point. So what we will do is we will call this function, and let's say for value 2, okay, so this should actually work. So when I run this, the values are 0 0 0 1 1 0 and 1 1, which is the correct value. So let's see how it is working. So we call the generate binary sequence with 2. 2 is greater than 0, so it will come over here. It'll make a result array of size 2. Call the generate binary sequence with current value 0. Current value is not equal to 2, so it will come over here. It will make the result of current, which is this one over here, to 0. Then what it will do is it will recurse with current is equal to current plus 1. So current becomes 1, and it will go over here and it will write the value 0. And then it will recurse again with the current is equal to current plus 1. So current becomes 2. When it comes back, current becomes equal to 2. It will print the results, which is 0 and 0. Next, what will happen is it will come back in the for loop, and it will change the result of current, which is 1 at that point, to 1. So what will happen over here is that it will change the value of this to 1. And then it will call the recursive function again with current is equal to 2. Current becomes equal to 2, and it will print the result 0 and 1. So this is how it will continue, and we'll get the binary sequence. Let's try this sequence with n is equal to 3 and see if we get the results. Okay, So we see with n is equal to 3 also we are getting the same, we are getting the expected results. So this is a binary sequence. Now let's discuss what is a M-Ary sequence. So let's say n is equal to 2, which means that we want values, we want a size 2, and m is equal to 3, which means the possible values is 0, 1 and 2. Okay, so for n is equal to 2 and m is equal to 3, the different values would be 0, 0, 0, 1, 0, 2 and 1, 0, 1, 1, 1, 2 and 2, 0, 2, 1 and 2, 2, which is basically 3 to the power 2, which is m to the power n, which is equal to 9. So in this case we have 9 different sequences. So that is called a M-Ary sequence. Okay, let's try and change this function. So this is basically, this becomes a M-Ary sequence. So M-Ary sequence. Let's make it M-Ary sequence. Okay, so this is the M-Ary sequence. Instead of n, we will provide m also. So this becomes 2, 3, where n is 2 and m is 3, as we discussed in the example. The generate binary sequence should also be changed to generate M-Ary sequence, and we will pass value m. Okay, so what is happening over here in M-Ary sequence, value of m comes over here, and the only change in this function that we need to do is instead of 2 we will provide m, because this is a M-Ary sequence instead of a binary sequence. So when we run this, we should get all the values, all these values. So let's run this and see if this works. Okay, so 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, which is the expected result. So as you can see that we just changed one value m, and then we can get a M-Ary sequence of size 3. Let's say if somebody asks you, you want to generate all the numbers from 0 to 9 and of size 2. So all we need to do is, because 0 to 9 there are 10 different values, so over here our m is equal to 10. So if we run this, we get all the values from 0, 0 to 9, 9. So this is using backtracking and basically recursion, and we'll use this function a lot to solve a lot of other questions. So looking forward to talking to you in the next video. Thank you.